Okay, so here we've got a linear equation. We've got two variables that makes it a linear equation. I'm going to rewrite this in function notation. It's almost the same thing. The only difference really is that the y is going to get replaced with f of x. My pen doesn't work. Okay, so here we go. F of x is going to be in the place of the y. Okay, in function notation, we have an input and an output. The input is what goes in for the x. The x is really the input. And the output you can kind of think of as the y. So it's this whole thing f of x. So that sometimes throws people off the f of x thing, but don't worry about it. It works very similarly to a y. The difference is when I've got something like this. In this next example, I've got f of x equals 3x minus 1. Okay? And then I'm supposed to find f of 5. That just means instead of x being my input, I'm going to input 5 in that position. So if f of x equals 3x minus 1, f of 5 is going to equal 3 times 5 minus 1. I just replaced the x over here with a 5. Okay? And when I substituted that in, I used parentheses. That's a good habit to get into. It doesn't really matter that much on this problem, but when they get more complicated, it does. Okay, and then I'm just going to simplify this using PEMDAS. So order of operations tells me that I should do multiplication before subtraction. So I've got 15 minus 1, and that's going to put me at 14. Okay, all right. So this next one is a little different. It's a little strange because my input is still going to be x. I'm not going to replace the x in here with a 2 or anything. The input of the function is still going to be x, okay? But this is the whole function, okay? So what I can do, I know that f of x is equivalent to 3x minus 1, okay? So I can just plug in the quantity 3x minus 1 in where the f of x is. That's what I'm going to do. So I'm going to have the function plus 2. The function is equal to 3x minus 1. So I'm going to replace this like so. Okay? And then I'm going to simplify this. And I could write this would look the same without parentheses, right? I just have the parentheses to show what I substituted in. So negative 1 plus 2 would be positive 1. So after I combine like terms, that's all I can do. 3x plus 1, those aren't like terms. That's as much as I can simplify. So f of x plus 2 is 3x plus 1, okay? Now, this one's a little different again because now I've got the input, instead of being x, is x plus 2, okay? So I'm going back up to my equation up here, and instead of x, I've got the quantity x plus 2, and here's where it's really important that you use parentheses, okay? So I'm going to have 3 times something minus 1. So I'm just going to write it like that first. 3 times something minus 1. The something is the quantity x plus 2. Okay, now if you forgot to use parentheses when you substitute it in, and I'm guessing that you might forget also to distribute the 3. Okay, and that's really important because when I simplify this, I want to make sure I do 3 times both of those terms that are in the parentheses. So I've got 3 times x is 3x, 3 times 2 is 6, and then I can still combine those like terms. 6 minus 1 is 5. So this is going to simplify to 3x plus 5. Okay? Notice, those look really similar, right? I've got f of x plus 2, and I've got f of x plus 2. But you get different results because here you're just adding 2 to the whole equation, and here you're inputting x plus 2. Okay? So on parts D and E, again, I'm going to be doing substitution. I know what f of x equals. Okay, so I'm just going to substitute. And when I substitute, I'm going to take the opposite of whatever that function equals. Okay, so the function here equals 3x minus 1, the quantity 3x minus 1. Very easy to make the mistake, again, of not using parentheses. And then, so some people will give me an answer that looks like negative 3x minus 1. That's incorrect because I'm really taking the opposite of both of those terms. You can think about distributing a negative 1. So I'm going to change the sign of both of those. So it's not just negative 3x minus 1, it's actually negative 3x plus 1. Okay, and I guarantee you a problem like that on a quiz or a test, a lot of people are going to miss the sign of that second term. Hopefully that's not you. Okay. All right. And then this last part, now I'm going to change the input. Instead of f of x, I've got f of negative x. So again, I'm going to the original equation. I'm thinking it's 3 times something minus 1. 3 times something minus 1. But my something here is not positive x, it's negative x. Okay? And then I'm going to simplify this. 3 times negative x would be negative 3x. Okay? So that's a little on function notation, how to use function notation. Okay? Now I want to talk about absolute value a little bit. Okay? Now this is something that most of you have probably seen before, and a lot of people right off the bat will tell me that the absolute value of negative 3 equals 3. And that is correct. Okay? The way that a lot of people think about this is, oh, I just changed the negatives into positives. And that's true to some extent, but that's an oversimplified way of thinking about this. It's fine for now, but later on things will get confusing if you just think of them as changing everything to positives. So what you want to do is think about a number line. So you want to think about a distance from 0. Okay, so here's 0 on the number line. So another way of thinking of this is, how far is negative 3 away from 0 on the number line? Well, here's negative 3. Right, there's 0. How far is it away? Well, some people might say it's negative 3 because you can go left, but it doesn't matter which direction. Okay, it's just a distance. It's a distance. That's why these are always positive. Distances have to be positive. You can't live negative 3 miles away from school, right? It doesn't matter what direction. Distances are always positive. So that's why the absolute value of negative 3 is 3. Okay. Now, I'm going to move on to graphing an absolute value function. So here we have f of x equals the absolute value of x. Now, if I just had y equals the absolute value of x, this would graph in the exact same way, okay? It's just I don't have an xy axis here, I have an f of x axis, but that's the only real difference when it comes to graphing, okay? So if you've never graphed a function that you come across or an equation, a good place to start is by just generating some points. Because if I can find some xy pairs that satisfy this equation or function, then I can put some dots on my graph, and then hopefully I'll be able to see what it looks like, okay? So I'm thinking, okay, well, what happens if I have 0 for x? Well, let's try it out. So f of 0, just going to plug in 0 there. And remember, this is really going to be the same as the y that comes with it. So f of 0, the value of my function when my input is 0, well, the absolute value of 0 is 0, right? It's 0 spots away from the number line. So that means 0, 0 is going to be on my graph. Okay, so let's put it in there. There's the point 0, 0. Okay, now let's try 1. Okay, and if you prefer, you can do it with the y, right? So if I'm putting in 1 there, the absolute value of 1 is 1. So that means when I plugged in 1 for x, I got out 1 for y. So 1, 1 is on the graph. Okay. And let's try 2. We can just do this in our head. The absolute value of 2 is going to be 2, right? So 2, 2 is on there. 3, 3 is going to be on there as well, okay? Let's look what happens when we put in some negative numbers, okay? So here, I'll move up here. So if I've got this, and I want to figure out what happens when I plug in a negative 1, okay, well, negative 1 is going to be 1 spot away from 0 on the number line. So when I plugged in negative 1 for x, I got out positive 1 for y. Okay, so I went 1 left, 1 up, right? Negative 1, 1. Same kind of thing. The absolute value of negative 2 is positive 2. The absolute value of negative 3 is positive 3. And if you plot those points, we're going to get something like that, okay? Now, it might be tempting to draw in a parabola because we've graphed a lot of those in the past, but this isn't a parabola. It's going to be more of a V shape than a U. So I'm just going to draw a straight line that goes forever in that direction and another in that direction. Okay, so there's no curves to this. It's just two straight lines that give me sort of a V shape. Okay, all right, let's move on to the next page. Okay, so this is our parent graph that we just graphed. It's your most basic absolute value function. So it's a V that opens up from the point 0, 0, and it goes up one to the right one, up one to the right one forever, and same going to the left. Okay, so we're going to be comparing our other functions to this one. So it's useful to just know what this graph looks like and not have to do an XY table. I did it because it's the first time we've seen that function, but in the future, I'd kind of just know, oh, it's a V opening up from 0, 0. Okay, so let's see what happens when we add in another component. Now, you can always do this with an XY table. Okay, so again, since it's kind of our first time looking at this, let's make a little table, at least to get started. So I want to see what happens when I plug in 0. I can plug it in anything I want. 0 is just the easiest number to plug in, right? So when I plug in 0 here, well, the absolute value of 0 is 0. So I get out 2 for y, okay? And let's see what would happen. I'm not going to write all of these out, but that's kind of what I'm going to do these in my head. So I'm going to take the absolute value of 1, which is 1, plus 2 is 3, okay? And let's try, I can see the next number I'm not going to have space for on the graph anyway, so I'm going to try putting in a negative number. Well, the absolute value of negative 1 is positive 1, plus 2 is 3, okay? And then if I put in negative 2, then I'm going to get the absolute value of negative 2 is positive 2 plus 2 is 4, okay? So let's try plotting these and see if we can get an idea of what this is going to look like. I've got 0, 2, it's right here, 1, 3, and then I've got negative 1, 3, and negative 2, 4, it's going to be off my graph a little bit, but it would be up here. Okay. Also, if I put in a positive 2 here, I'd get, you can kind of see where the V is. This is another V, okay? And if you compare this to the previous graph, this is a little sloppy, sorry about that, but if you compare it to the previous thing, it's just another V, but it's moved up 2 units, okay? So what that plus 2 is going to do is move my graph up 2, okay? So if I had a minus 3, that's going to move the V down 3, okay? So when you're adding or subtracting something to the outside of the absolute value, it's just going to move your graph up or down, your V up or down, okay? Now, it's pretty easy once you know that pattern, but it's also easy to confuse it because here you see the plus 2 is inside the absolute value function. It's going to be a little different, okay? So let's look at an XY table again. Let's put in 0 for x. So I've got the absolute value of 2, which is 2. Okay, so I've got the 0.02 again. Let's try putting in 1. So now this is going to be interesting. So I've got 1 plus 2. That's 3. Well, it's not that interesting yet. But let's see what's going to happen if we move to the left. So so far it looks the same as that one, right? But let's see what happens when we plug in a negative 1. Okay, so maybe I'll do that over here. Oops. Okay, so if I plug in a negative 1 for x, then I've got the absolute value of 1, which comes out to 1. Okay, so now this is looking different, right? Okay, so let's keep going. I'm going to see what happens when I plug in a negative 2. Negative 2 plus 2 is 0, so the absolute value of 0 is 0. Okay, so if I start graphing these, I'll get to that in a second. I've got 0, 2. I've got 1, 3. I've got negative 1, 1. I've got negative 2, 0. If I just graph that, I really need to find the vertex. I need to find the bottom of the V, and I don't know where that is yet. Okay, so that is super important because I know it's going to be a V, so I need to find that turnaround. So I'm going to keep going here until I find it. So if I plug in a negative 3, now I've got the absolute value. Negative 3 plus 2 is negative 1. Absolute value of negative 1 is positive 1. Negative 3, 1. There we go. found the turnaround. Okay, so now I can draw in my V. So that's just going to continue in that pattern forever in that way. Okay. By the way, I don't have to plug in, I could plug in 2.3 or whatever I want, but I'm just using these nice integers just because they're the easiest to use, right? Okay. All right. So, well, let's see how that changed. When I had this, it went up 2. When I had this, it's gone left 2 from the parent graph, right? The parent graph had the vertex right there going up. So it's actually gone left 2. Okay? So it's maybe a little different than you might have guessed. So when you've got something added or subtracted inside the absolute value, it moves it left or right. And when it's positive, it goes to the left. When it's negative, it's actually going to go to the right. Okay? So I'm going to start using these patterns here. So you could always go through with an XY table, right? But let's try to make this go a little quicker. So if that went left 2, that was inside, this is going to make this go right 2. Okay? And then when you have something added or subtracted on the outside, that makes it go up or down. So since this is positive, it's going to go up 1. Just like on this problem, this one went up 2, right? So really all I need to do is find the vertex, and then it should have the same shape. These are all going to be V's that open upwards for now. Later on, that's going to change. Let's see. So if I go, why did I write 2? That should be right 3. That's what I meant. Okay, so I'm going to go from the point 0, 0. I'm just going to go right 3, up 1. 1, 2, 3, up 1. And that should be the vertex. Okay, and then so to find the rest of the points, I'm just going to follow this pattern, right? I'm going up 1 to the left 1, up 1 to the left 1, and up 1 to the right 1. Okay, so on any of these problems, I'd want you to plot at least 3 points. You need the vertex and 2 other points to kind of show where the V is going. You could do more if you wanted, but 3 would be the minimum. Okay, and there I've got my absolute value function. There's my V. Okay, so this gets a little trickier when we add this new component. Now we're going to have some negatives in the mix. Okay, so let's make an XY table. I'll just do this in my head. Okay, a negative 0 is just 0, so the absolute value of 0 is 0. Okay, when I plug in a 1, I'm going to have the absolute value of negative 1, right? Because I got negative 1 in there. Absolute value of negative 1 is positive 1. Okay, and when I put in a 2, absolute value of negative 2 is positive 2. All right, so far I've got this business happening. So it seems like, oh, maybe it's just going to open up like the original one. Well, let's try some negatives. So when I plug this in, remember I'm going to have a negative, the opposite of negative 1, really, right? I'm plugging in negative 1 for the x, so that's going to be positive 1 in there. But then the absolute value of that is just 1. Okay, when I plug in a negative 2, the opposite of negative 2 is positive 2. Absolute value of positive 2 is 2. Okay, so this actually does look exactly the same as the parent graph. Okay, now in reality, this V is going to be flipped from the original. Okay, now you can't really see that because when I rotate this over the y-axis, it's still just going to look like a V. So it's not going to have any difference right now, but what this is actually going to do is reflect over the y-axis. Okay, now this one, about the problem above it, if I reflected this over the y-axis, yeah, it'd still be a V opening upwards, but it would be over here on the left part. It would be a mirror image of that over the y-axis. Okay, but when it's centered right on the y-axis, you can't tell that it's reflected. Okay, all right, so one more XY table here because we've got to develop these patterns. I want to show you why this stuff works the way it does. So I've got the opposite of the absolute value of 0. Well, the absolute value of 0 is 0. The opposite of that is 0. Okay, so 0, 0 again. Let's try plugging in 1. So this is when I'm plugging in 1 here. And that's going to come out to negative 1. Okay, when I plug in a 2, So that is going to be -2. And so you can kind of see the pattern here, right? That's going to come out to -3. But let's see what happens when we plug in some negatives. So when I put in -1 for x, okay, absolute value of -1 is 1. Then I've got that opposite out there, so this comes out to -1, okay? And the same pattern is going to hold true over there. So let's plot these. I've got 0, 0, 1, -1, 2, -2, 3, -3. Then I've got -1, -1, -2, -2, -3, -3. Look at that! It's opening downwards. Okay, so when the negative was inside the absolute value, it flipped it over the y-axis. This is going to reflect it over the x-axis. You know, the original one opened up like that, right? But if you flip it over the x-axis, then it's going to open down. So when you've got a negative right here, reflect over x-axis. Okay, and once you learn these patterns, it's a lot quicker to graph these than making the XY tables. Okay, let's move on to the next page. Okay. When graphing absolute value functions, find the vertex before reflecting. Okay, not all absolute value functions are going to have reflections, but if it does have a reflection, find the vertex first. Okay, so both of these examples do have a reflection because I've got a negative there in front of the x, and here I've got a negative in front of the absolute value function. Both of those are going to be reflections. Okay, but before I worry about the reflections, I'm going to find the vertex. Okay, so here's how I'm going to do it. I can tell that for this, I can tell that this is going to move everything up 1 unit, right? And this is going to move everything down 3. Okay? So when I'm thinking of my vertex on this first one, I know since it's moved down 1 from the origin, my y-coordinate, sorry, up 1, I mean, my y-coordinate is going to be 1 there, okay? And my y-coordinate over here is going to be -3. Okay, so that's kind of the easier part, is getting the y-coordinate, because you just look if anything's added or subtracted outside of the absolute value. Okay, the harder part is finding the x value. So yes, this does move things left 2, but that negative is actually going to screw this up a little bit. Okay, so what I want you to do to find the x coordinate, so you know, actually this will give you your y, right? This is the y of your vertex. But to find the x, what you're going to do is take the contents of the absolute value function and set it equal to 0. So I'm going to say -x plus 2 equals 0. And then I'm going to solve that for x. Okay? So I'd want to subtract 2 from both sides here. So that means -x is going to equal -2. And then you can multiply or divide by -1 on both sides. So my x coordinate here is going to be 2. Okay? So that negative actually did affect the x coordinate. It's not just -2, 1 like you might guess. It's actually +2, 1. Okay? And when I go to this one, I'm just taking the contents there to find the x coordinate. That negative actually doesn't affect it. So I'm thinking, okay, x plus 1 equals 0, and that means x is -1. So here, my x coordinate is -1. Okay? So I'm going to put the vertex in place on both of these before I worry about the rest of this. This is 2, 1, and then this is -1, -3, okay? Now I'm just thinking, okay, is this going to open up or down? That's all I have to do now, okay? Now, remember, if you have a negative inside there, it's going to just reflect things over the y-axis, so it's just going to do this kind of thing. So it's not going to affect it going up or down. So this one is actually going to open upwards from there. So I'm just going to go up 1 to the right one, up 1 to the left one. And you could go another step on the ladder if you wanted, but your absolute value function is going to look like that, okay? When you have something on the outside like this, it's going to reflect over the x-axis. So this is actually going to flip things, okay? So this is going to make things open downwards. So if there's no negative in front of the absolute value, it's going to open upwards. This one's going to open downwards, and unfortunately I didn't leave myself too much space here. I'm going to have to go off the graph a little bit, but oh well, I guess I didn't plan that out. Great. So I'm going to go right one, down one, and left one, down one, and this is going to look like that. And again, you can always, if you don't believe me, you can do an XY table to find some points and figure it out. Right? You could plug in a 0 for x, so this would give you, 1 in there. Absolute value of 1 is 1, negative 1, minus 3 would be negative 4. So 0, negative 4 would be, you can test it like that. Okay. All right, so let's recap what all of these transformations are going to be. If I've got something inside, this actually works the same as this is just function notation. But so this is going to work for absolute value functions, but actually all other functions as well. When instead of f of x, if I've got f of x plus h, that means I'm going to move everything left h units, whatever h is. So if I had x plus 4, I'd go left 4 units. If it's a minus something in the middle, then you're going to go right that amount. So if I had, x minus 4, then I'd be going right 4, okay? When you've got something added to the outside, that's going to move the whole function up, whatever h is. So if I had f of x plus 7, up 7. If I have f of x minus 7, that's going to move everything down 7, okay? And then when I'm changing the inputs, I'm changing the sign of inputs like this. This is going to reflect over the x-axis, over the y-axis, reflect over y-axis. And then this one is going to reflect over the x-axis. And another way you can think of that is really flipping your graph upside down. So for these absolute value functions, it means they'd be opening downwards. Or if this was a parabola, it'd open down if you had a negative like that. Okay? All right. So let's look at this from a different perspective. Now we're going to be writing equations. Okay? When it says write a rule for g of x, that just means write an equation for g of x. Okay? So just think of that as saying equation or function. Okay? So this says a translation. A translation is sliding things left or right. Okay? So this is a slide. So that means it's moving something either up, down, left, or right. Now in this case it's left. So if I want if f of x looks like this, then I'm thinking, well, what can I do to move this to the left 5? Well, let's use this little guide. If I want to go left, I'm going to use something like that. Okay? So if f of x looks like this, g of x is going to be equal to f of x plus 5. Okay? So now I'm going to actually write what f of x plus 5 is. And remember, that's just inputting x plus 5 into the input right there, right? Okay, so I've got 2 times something plus 3, like that. And that something is going to be x plus 5. X plus 5 is my input, right? So that goes right there. And now I still want to simplify this. Okay, I'm running out of space, so I'm going to have to move to the right here. But I want to distribute the 2. Okay, and I've still got the plus 3 on the end there, right? And then I want to combine these. Okay, so if you just said the answer is 2x plus 13, I'd probably accept that, but we really want to write a rule, which means you really want the g of x equals 2x plus 13. Just a lot of times people forget that g of x equals, but it's not an equation if you just write 2x plus 13 as your final answer, right? Because that's just a it's not an equation. It's an expression. Wow, I couldn't think of the word expression. Got it back. Okay. Yeah, all right. So now let's do a reflection over the x-axis. So I'm going back and thinking reflection over over the x-axis is going to come from negative f of x. That's going to give me my reflection. Okay. So now I just have to substitute in. Well, I know what f of x equals. F of x equals this. Okay. So when you substitute, you use parentheses. It's the quantity 2x plus 3. When I say the quantity, I mean that part's in parentheses, okay? And then the parentheses are reminding me, oh yeah, I've got to distribute. I'm taking the opposite of both of those terms, not just the opposite of the first term. Okay, and here I'll put in g of x in both of those places. And now I've written a rule. This would be, if I graphed both of these are just straight lines, but if I graphed them, they would be this one. If I reflected over the x-axis, I'd get this one. Okay. That's it for this video. I'm going to do the. I'm going to continue the section in the next video. It's a little bit involved, so I'm going to save it. So that's it. See you next time.